NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will learn how to write a negative logarithm in characteristic.mantissa form, where the mantissa is always non-negative. Key rule: the mantissa must be between 0, inclusive, and 1, exclusive. If a logarithm is written as minus n point p, the fractional part p is negative and cannot serve as the mantissa. We rewrite minus n point p as minus n plus negative 0 point p. Here is a simple visual. A number line from 0 to 1. The mantissa always lives in this interval. Now, we follow the standard algorithm step by step to convert minus n point p into a valid characteristic and mantissa form, without changing the order or the wording of any step. Step 1. Log base a of n equals minus n point p. Step 2. Therefore, log base a of n equals minus n minus 0 point p. Step 3. Therefore, log base a of n equals minus n minus 1 plus 1 minus 0 point p. Step 4. Therefore, log base a of n equals negative n plus 1 plus 1 minus 0 point p. Step 5. Therefore, log base a of n equals overline of n plus 1 dot p prime semicolon 0 less than or equal to p prime less than 1. Conclusion: in this case, the characteristic is minus n plus 1. The mantissa is p prime equal to 1 minus 0 point p. Let's cement the idea with a concrete example using base 10. The common log of 0.05 is about minus 1.3010. Here n equals 1 and p equals 0.3010. Applying the algorithm, the characteristic becomes minus 1 plus 1, which is minus 2. The mantissa becomes 1 minus 0.3010, which equals 0.6990. Visually, the new mantissa is simply the complement of p to 1. If p is about 0.301, then 1 minus p is about 0.699. Recap: for a negative logarithm written minus n point p, separate the integer and fractional parts, add and subtract 1, then group to get minus n plus 1 plus the quantity 1 minus p. The characteristic is minus n plus 1, and the mantissa is 1 minus p, which lies between 0 and 1. In this lesson, we will find the characteristic and mantissa of a negative common logarithm following the exact 4-step algorithm shown here. The problem is log of x equals negative 5.278. We'll rewrite it step by step so the mantissa becomes positive while keeping the value the same. Before we compute, a quick picture helps. Here is a number line near negative 6 and negative 5. The blue point marks negative 5.278, which lies between negative 6 and negative 5. By moving 1 unit left from negative 5 to negative 6, we can rewrite the number as negative 6 plus 0.722. This is exactly the goal of the algorithm: keep the mantissa positive. Step 1. Separate the integer and the fractional parts exactly as written: negative 5 plus negative 0.278. Step 2. Add and subtract 1 to prepare a positive mantissa: negative 5 minus 1 plus 1 minus 0.278. Step 3. Combine the integers and the fractional parts. Negative 5 minus 1 equals negative 6, and 1 minus 0.278 equals 0.722. Step 4. Write in standard bar notation for a negative characteristic with a positive mantissa. Therefore, the characteristic is bar 6, and the mantissa is 0.722. General rule: whenever the mantissa is negative, decrease the characteristic by 1 and subtract the fractional part from 1 to make the mantissa positive. In this lesson, we will prove a classic theorem about the mantissa of a logarithm and build an intuitive picture for what actually changes when we multiply a number by the base raised to an integer power. Theorem: if log base a of n equals n plus p, where n is the characteristic and p is the mantissa, then multiplying or dividing n by an integer power of the base changes only the characteristic. The mantissa p stays the same. To visualize this, think of a logarithm as 2 parts placed side by side. The orange block is the characteristic and the green block is the mantissa. Let m be an integer. We start with the product inside the logarithm, using the product rule of logarithms. Next, Apply the power rule to the term log base a of a to the m. Since log base a of a equals 1 and log base a of n equals n plus p, substitute both into the expression. Combine the integer parts together. This gives m plus n plus p, or grouped left parenthesis m plus n right parenthesis plus p. Visually, that means the mantissa block on the right stays exactly the same, while the characteristic block gains m more units on the left. The fractional part, the mantissa p, is unchanged. Therefore, when we multiply n by a to the m or divide by a to the m, the characteristic changes by plus or minus m, and the mantissa p remains the same. Quick check with base 10. Suppose log base 10 of n equals 2.34. So n equals 2 and p equals 0.34. Then log base 10 of 10 times n is 3.34. The mantissa 0.34 stays the same. The characteristic increases by 1. That is the mantissa theorem. Integer powers of the base shift only the characteristic. The mantissa carries the fractional fingerprint of your number and remains unchanged. Example: we are told that the mantissa of log base 10 of 5 is 0.698. Using that, find log of 0.005 and log of 0.2. First, a quick reminder. A common logarithm splits into two parts, the characteristic, which is the integer part, and the mantissa, which is the decimal part. Numbers that share the same sequence of digits, like 5 and 0.005, share the same mantissa. Only the characteristic changes. Let us find log of 0.005. Write 0.005 as 5 times 10 to the power negative 3. Then log of 0.005 equals log of 5 plus log of 10 to the power negative 3. Log of 10 to the power negative 3 is negative 3. So the mantissa stays 0.698 and the characteristic becomes negative 3. We write this as bar 3.698. Summary for the first part. Log of 0.005 equals bar 3.698. Now let us find log of 0.2. First, compute log of 2 using the quotient idea, since 2 equals 10 divided by 5. Log of 2 equals log of 10 minus log of 5, which is 1 minus 0.698. That is 0.302. Then log of 0.2 is log of 2 plus log of 10 to the power negative 1, which is 0.302 minus 1. So the characteristic is negative 1, written as bar 1, and the mantissa is 0.302. Final result, bar 1.302. Therefore, the answers are log of 0.005 equals bar 3.698, and log of 0.2 equals bar 1.302. Tip: for decimals less than 1, count the number of zeros after the decimal and before the first non-zero digit. The characteristic is the negative of that count plus 1. The mantissa depends only on the digits, not on the decimal point location. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.